All right, we're going to go ahead and start talking about the lesson for today, which we're going to do binomial and geometric, but we're going to do cumulative items. So like exactly how much this is versus if you have at most this or at least this. So we're going to cover those, kind of also summarize what we have been doing. And so that's on page 53 and 54, and your homework will be the 12 days of statistics, which is on page 55 and 56. And when you do those, I wanted to let you know if you do things to 3 significant digits, and I'll show you this again whenever we get to it. But if at the bottom of page 56, it gives you a little hint that if you do things to 3 significant digits, then you could sum them all up and you could check yourself. But hopefully this will be short enough that you guys can work together during class to also kind of check yourself as you go along. All right. Now, you also picked up this tree map or this classifying map where we're talking about geometric and binomial. So let's kind of summarize this stuff right now. It's our discrete probability that we've been talking about this unit. So we've talked about how geometric goes until you have a success. So you are told the place that the success will occur. And what we've talked about so far is the exact place of the first success, and that's when you do your geometric PDF. And we have also talked about this part. The first success happens on or before a particular place. And so we've done the geometric CDF of that location, of that percent up to that location. And finally, of course, we have done the formula on the formula chart is your geometric expected value. You know, expected value is the mean. Expected value is the mean. Geometric 1 over P, binomial N times P. And then the standard deviation here. All right, so today we're going to learn how to handle this piece here. All right, and then yesterday we talked about binomial distributions. So we talked about how binomial is happening when they tell you a set number of trials. Out of 10 cars, what's the probability? Exactly 6 of them are wearing their seatbelt. And we did that and that alone yesterday with the exact number of successes, binomial PDF. And we did talk about doing the mean and standard deviation for that. And we did a little bit of normal model stuff after that. All right. So our goal today is to make sure you can kind of tell the difference in those and then learn about these cumulative ones for binomial and this particular cumulative one for geometric. All right, so let's go forward and let's take a look in your notes at page 53. So here we go, page 53. We're going to go ahead and start with, again, and this problem talks about K successes, where on our formula chart it uses X successes. But let's go ahead and talk about this. This is saying yesterday we did the binomial PDF problems where we had an exact number of K successes. So I want you to read this first problem and go ahead and write out your formula and compute. I'll go ahead and put the formula up here as well. So out of 50, we want 10 successes, and 13% of them are left-handed, and we want 10 of those. So 87% are not left-handed, and that would make the remainder of them, that's the failures, so 40. Remembering that, you can always tell that this failure plus success is the total N. All right, so I went and I put this into my calculator. What I typed in my calculator was binomial PDF of N, then the success rate, and how many of those I want, and that came out to be 0.0539, or 5.39%. Okay, so now let's take a look at what's happening here. We say we want to find the probability of at most a certain number of successes. So we're going to find out of 50 men, what's the probability that at most 15 of them are left-handed? So according to what we know, that would mean we would have to do a whole lot of these PDFs added together. We would have to add together 0 left-handed men plus exactly 1 left-handed man plus and all the way up to exactly 15 left-handed men. So that is crazy, having to compute all of these binomial PDFs and adding them all together. So there is a cumulative feature on the calculator that we're going to take advantage of. And so we're going to do that. And so we'll write out our formula such as this, the probability that we have successes are less than or equal to 15. Because let's think about this. Let's get this equal to or not equal to. If it says at most 15, can you have 15? So at most 15. And so that's yes, as long as it's not more than 15. At most, the most it can be is 15. All right. So the way we write this is we do similarly as to how we did our geometric cumulative. We are going to show the first in the sequence up to, so we're going to do the first in the sequence. So I'll kind of notate that. We're going to do the first, which is actually 0 successes. And then we're going to go plus dot, 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 plus, and then we're going to do the formula for the last in the sequence, which is the x equals 15. So I'm going to show the formula for both of those two, and then I'm going to use my calculator. So here we go. So let me do this formula for 0 successes. That's 15. Choose 0. So there are 0 lefties. Oh, pooh. You know what? That's wrong because our n is not 15. So I had my little first part written incorrectly. So sorry there. This is out of 50 men, I want 0 successes. There we go. And then now I got 0.13 to the 0 lefties. And if there's 0 lefties, then how many are not lefties? And that is 50 because, again, remember, failures plus successes is the total N. Okay, now we got plus, that was the first in the sequence, plus dot, 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 plus, and now we're going to do the last in the sequence. So here we go. So the last in the sequence is up to the 15 successes. So out of 50, I have 15 successes. So that's your 0.13 to 15 successes. 0.87. Now, discuss amongst yourselves if there are 15 successes, then how many failures are there if they total to 50? Okay, so that is 35. All right, So we want to accumulate in our calculator 0 up to 15 successes. So here's how that works. I'm going to write out the computing. So we're going to go binomial C, D, F for accumulate. Binomial C, D, F for accumulate. And we have out of 50 trials, that's our N, the probability of success is 0.13. And how many do we want? How many successes do we want to go up to? This number here, this number that goes right here is the up to and including. And that is critical that you understand this. So this number that we're going to put into the calculator right here is up to and including. So in this case, we do want to include 15. So this is up to and including 15 successes, 15 lefties. All right, so let's go to our calculator, which here we go. And you're going to go to second vars and the distribution. So we're going to go to the second distribution. And we want binomial CDF. So second vars, I go up to binomial CDF, not PDF. PDF would be used if it said exactly 15 successes out of 50. But we want 50 is the N. 0.13% of them are lefties, and I want up to and including, I want to accumulate up to and including 15 successes, and there it is, 0.9996. So that's very high probability. So our answer is 0.9996. All right, let's try another one. So here on this one, we want to find the probability of at least a certain number of successes. Okay, if we, out of these 50 items, if we wanted to do at least 15, then what does that mean that we want? Okay, so let's talk about this. If we want at least 15 successes. Okay, so actually, let me write out this little sequence here just real quick so I can have a little discussion with you. There's 0 successes, 1 success, 2 success, 3 success, and so on. I'm going to kind of do a little section here. 14 successes, 15, 16, 17, and so on up to 50. So let's say these represent the number of successes. So I want you to circle how many successes, what section do we want if we want at least 15? At least 15. If we want at least 15, we want there to be 15 successes or 16 successes or 17 successes or ... so on up to 50 successes. We do not want that lower part. All right. Unfortunately, however, our calculator, unless there are some updated, I think the Inspire does this, there are some updated operating systems that can compute all different areas. But our calculators only can compute the lower portion. Remember how we would have to do inverse norm of the area below is the z at that spot? We would always have to do the lower portion because our calculator only can do that. That's the computing capabilities we have. So let's see here. So let's go ahead and write the formula, and then we'll talk about how to calculate. So here comes our formula. We want to find the probability that we have greater than or equal to 15 successes. All right. So remember, we're going to write out the first formula. So the most you have to do is 2 formulas. We're going to do the first formula, which is probability that we have 15 plus ... plus the last one, which the last one is, what's the most amount? 50. Okay. And what I just put in black there, you don't have to show that. I'm just writing that out for you and demonstrating it. Okay, let's do our 2 binomial formulas. First one. Okay, so you try to fill that in. N choose K, or 15 successes. Okay, and I was just going to erase the part that you don't need. Okay, all right, so there is the work that gets shown. Now we're going to go ahead and compute our answer. So let's discuss this. The calculator, remember this discussion right here. The calculator can only compute this amount here. Okay, so let's get that. The calculator can compute that amount. Unfortunately, that's not what I want, but that's all the computer can give me, calculator can give me. So let's do that. I want cumulative binomial CDF of out of 50. Probability of success is 13. Now, quick question. This is an important thing here. Okay, so pay attention to this. All right. I want 15 and above. I want 15 and above. So I will be taking 100% of everything and taking off this lower part. Don't you take off this 15. You do not want to be subtracting off 15. You are subtracting off 14 and down. So the key to this is always thinking, and I write this out myself. I write out that little sequence, and I mark a little X on what I don't want and what I do want. I want 15 to 50, so I'm going to take off the bottom 14. So in my calculator, I am taking off the bottom 14. So the bottom 14 is 0.9987. So if I know this amount is 99.87% of data, then this has to be the rest. So I do 1 minus that 0.9987, and that's how I get my 0.0013, or a very small amount of 0.13%, whichever way you choose to do it. Okay. All right, so that's as tricky as it gets, guys. The rest is just paying attention to what you want and what you should be subtracting. And so I'm going to let us now practice the other part. FYI, well, we can kind of take a look at our thinking map and take a look at this. See if we want less than or at most a certain number, then you do the binomial CDF. That lower part, if it wants the lower part, then you just binomial CDF it. Okay? If it wants more than or at least. If it wants the upper part, then you do 1 minus the lower part. If you want the upper part, then 1 minus the lower part. If you want the upper than with 1 minus lower, you can. If you want the upper than with 1 minus lower, you can. And that's the same thing with this geometric part. If you want the upper, then you can do 1 minus the lower. All right, let's try some more examples. Let's just see how you do on this. So let me give you a few minutes to take a look at this. If Aledo ISD parking tickets in the teacher's parking lot are given out approximately 2 days a week. So that's 2/5 of the time. So what's the probability that you will get at most 14 tickets in the 178 school days that you attend? So 2/5 of the time, so let's say you're parking there, what's the probability you will get a ticket if they check it 2/5 of the time and they find you on those times? 40%. So the chance of a ticket is 0.40. What's the probability you get at most 14 out of the 178 days? So N is 178 days. You want your successes to be less than or equal to 14. All right, so let me give you a few minutes to try that one. Go. So let's take a look at what I wrote here. See how you're following along. So remember this here. So I want from 0 up to 14 because I can have 14. I'm going to allow 14 tickets. So this is representing 0 tickets. So that's why this is 0.40 to the 0 and 78 non-tickets. Plus my dot, dot, dot. So that's my sequence. Okay, so look at what this last one is doing. That's representing 14 tickets. So 0.40 to the 14, and look at here, 0.60. How did I get 164? So the way I got 164 is because I knew that 164 plus 14, something plus 14 has to total to 178. So that's how I got 164 there. All right, now I need to accumulate. I got my plus dot, dot, dot. So I'm collecting 0 up to 14 successes. So I'm accumulating. So I'm doing binomial CDF. And out of 148.14, 0.40, 14. Oh my goodness. So there's basically a 0% chance if you park in the parking lot, the teacher's parking lot, and they check 40% of the time that you're going to get at most 14 tickets. You're going to get way more than 14 tickets. Okay? That's the probability. All right. Try the next one. So because this is a problem where it's exactly this or exactly that, PDF is what you use, not accumulating. So out of 152 patients with lung cancer, 60% chance of them being smokers. I want to see what's the probability that I would have gotten 75 smokers in there. So not very much. So 0.19% chance, so pretty low. So, and we're going to talk about what that means in terms of maybe that means the lung cancer rate is actually higher, or the smoking rate is higher than 60% among lung cancer patients. All right. Now, how did I come up with this number 77? Because 77 plus 75 is 152. All right. And so on. So let me see. Here's an at most and here's an at least. You know what? Let's try one that says, what if it says less than? Let's do less than instead of at most, and let's see what happens with that. Okay, so try this one. Less than 50. And this will be the last one I'll go over with you. If I want less than 50, then what's the top number of successes? 49 is the top number. So 103 failures. Okay, so now let's talk about this. I want from 0 up to 49. So when I binomial CDF, I want the 152.6 and 49. I want 49 and below. And honestly, it's a really, really, really small number. calculated a different number, so let's see. Binomial CDF of 152.60 and 49. Yeah, see 4.37. You have to pay attention. Look at the end of this line, times 10 to the negative 12ths. So 4.37 times 10 to the negative 12ths. And so that's basically a 0% chance that you're going to have less than 49. I got to thinking that I really do want to do just one more with you. And it's this one because I want to change this to more than 85 patients. Okay, because I want to just make sure we're getting the correct accumulation. All right, so last problem, promise, and then I'll let you go on your work. So we know we still got 152 patients. We want greater than 85. All right, and our probability of being a smoker if you have lung cancer is at 0.60. Okay, so let's go ahead and write our work, and then we're going to talk about what you compute. I want greater than 85. So the first one in my sequence is what if I want greater than 85? 86 successes is the first because I want more than 85. And so if I want more than 85, then I have 66 failures. Okay, that's the first in the sequence, and let's do the last. And of course, that's our 152 to 152, 152 successes and no failures. Okay, now here's the trick. Let's talk computing. All right, so let me just show you. I like to do these little series here, series of items. Let's go 83, 84, 85, 86, 87, and then up to 152. Okay, I want to circle the part I want, or I'm going to highlight the part I want. More than 85, so I want 86 and above. That is what I want. So if I want 86 and above, okay, if I want 86 and above, then what does that mean? I need to take off when I accumulate our different section. Let me try this here. So when I want 85 and above, when I want 86 to 152, I want to take off. That's what my calculator is going to give me. So let my calculator compute binomial CDF of 152.60, and I want to take off 85 and below. And again, that's because I want more than 85. So if you need to know what you take off or what you don't, this little sequence is the key. Picture what you want. Take off what you don't want. That's the answer. So I'm going to do 1 minus, I'm going to take off my accumulation of 152.6, and I'm taking off the bottom 85. So that ends with 82.75. So when I do 1 minus this binomial CDF, when I take off the bottom 85, I get 82 point, what did it say? 82.75%. All right. So that is hopefully how you can remember to do your at leasts, at most, more than, less than, and this thinking map may help you remember all those things plus your notes. So your assignment is going to be these 12 days of Christmas, and I believe that that's on pages 55 and 56 in your packet, and so that's what you're going to be working on for the rest of the class period, and you definitely want to help each other because this basically mixes up everything. So this is a mix of all probabilities. All right, have fun with that.